So in this video, we're going to be looking at solving geometry problems in 3 dimensions. So our first example is looking for the height of a cliff. So we're trying to find, in this case, the length of the line from C to D here, that height right there. But what I know is a bunch of things that are easier to measure. So it's hard to just measure the height of a cliff. But say you've got a surveyor, well, what she could do is she could stand at point A, and she could measure the angle between some point that she chooses at the base of the cliff and the shoreline where she's standing, and measure that to be maybe 51. Then she can walk over 150 meters, and that's relatively easy to measure because it's just all horizontal. So she can walk 150 meters over to point B, measure that angle again between the same point at the bottom of the cliff and the shoreline where she's at, and that would be 62 degrees. And then she can work with that information to try to work backwards to get the height CD there that she's looking for. The first thing that you really need here is actually the width of the river. We don't know the width of the river. That's another thing that's kind of hard to measure, but we can figure it out this way. So if we look here, there's a nice triangle. I'll redraw it over here a little bit bigger, maybe down here actually, so you can see better. So this is the triangle ABC. This angle in here is 51 degrees, and this angle in here is 62 degrees. And this side is 150 meters. Now, if I look at this, what I'm really trying to solve for is the width of the river over here, which is side B. So that's really what I want to know is side B. I can't use Sohcahtoa because I don't have a right angle triangle. Can't use Pythagoras' theorem because I don't have a right angle triangle. So I have to use either sine law or cosine law. This looks kind of like a sine law situation. I have two angles and an opposite side, sort of, but I'm missing this angle in here. Fortunately, I can actually figure out this angle though. So angle C, I do know that all the angles in a triangle add up to 180 degrees. So all angles in a triangle add to 180 degrees. So that means that angle C plus 51 degrees plus 62 degrees will equal 180 degrees. Or in other words, C is going to be 180 minus 51 minus 62. So we can plug that into our calculator, and we get 67 degrees for angle C. All right, so this angle here is 67 degrees. Now that I know that, I can actually just set up my sine law to solve for angle B, or side B, sorry, here. So I know the side C and the opposite angle. So this is side C, right? Remember the side letters are opposite their angle. So if this is angle C, that must be side C. So C over sine of angle C will equal B, that's what I'm looking for, over sine of angle B. I need to rearrange this for B, so I'm going to multiply both sides by sine of B. That's going to clean the sine B off the bottom there. And I'll get C times sine of B here on top, divided by sine of C, and that'll all equal side B. All right, so I'm ready to plug my numbers in here. So just do this over here. So B is going to equal C. Side C is 150 times sine of angle B, so sine of 62, divided by sine of angle C, which we solved for with 67 degrees. And you can plug all those numbers in, so 150 times sine of 62 divided by sine of 67, that gives me 143.88 meters. All right, so that just told me the width of the river. The width of the river is at 143.88 meters. Let's use that now to find that height, that length CD there. So what I'm going to want to do now is actually redraw a new triangle. So that's this triangle here, triangle ACD, that one there. I'm going to redraw it over here. One thing you want to notice here that's maybe not immediately apparent from the picture is that that's actually a right angle triangle. there's a right angle drawn in there, but it also makes sense intuitively. This side here that we just solved for, which is the 143.88 meters, that's the width of the river. That's a horizontal thing, right? The river is flat, so it's horizontal. Whereas side CD here, maybe we could call that H, that's the height of the cliff. So H not for hypotenuse, but H for height of the cliff. And a height is straight up and down. So it makes sense that that must be a right angle. The difference between sort of a horizontal thing and a vertical thing must be 90 degrees. The other thing you can see on this picture is that little angle in here is 32 degrees. So because this is a right angle triangle, I can actually use Sohcahtoa to solve this one. So if I write out Sohcahtoa, notice I'm looking for, if this is the angle I know, but I'm looking for the opposite side. And what I know is the adjacent, so it makes sense to use the TOA part. So tan of my angle will be the opposite divided by the adjacent. Now the angle that I have is 32 degrees. The opposite side is at height, so not hypotenuse again, but that's height, divided by the adjacent side, which is 143.88. And all I have to do is rearrange for h, so we'll want to multiply both sides by 143.88 to get it off the bottom. And we get h will equal 143.88, the width of the river, times tan of 32. So we'll plug that into your calculator. And that gives me h is 89.9 meters. So the height of the cliff is almost 90 meters tall. Now let's try another example. So here's a square-based pyramid. So that's a pyramid that has a square on the bottom. And all the sides of that square are length x. So that's an x there. What I'm trying to find out is the total area of the pyramid, and we're going to make an equation for it in terms of x. Also asked to make it an exact equation. So that means if there's going to be any square roots or something in there, I need to leave them as square roots. I don't want to round things off to decimals. So if there's like a root 3 or root 2, I would just leave that as root 3 or root 2. All right, so think about how we should tackle this. Well, it probably makes sense to find the area of one of these triangles. So I'm just going to redraw this triangle over here in 2 dimensions. I find this helps a lot when you're solving 3-dimensional problems. Redrawing things in 2 dimensions makes your life a lot easier. So this is actually an equilateral triangle. That's 60 there. And we know the height is h. Well, we don't know what it is. We know that's h though. So that's h there. And we know the entire base is x all the way along there. What I can do though is actually make an equation for h. So we're going to look at this guy right here. So that right there is a right angle triangle. And I can actually create an equation for h here. If the entire base is x, then this distance right here, from here to here, well, that must be half of x, right? If the whole thing is x, I'm looking at half of x for this little piece. So this must be half of x if the entire distance across is x. And then I can actually make an expression for h using Sohcahtoa. So Sohcahtoa tells me that tan of my angle is equal to the opposite over the adjacent. Now for us, the angle is 60 degrees. And the opposite side is h, and the adjacent side is a half of x. I'm trying to make an equation here for h, so I'm going to rearrange this for h by multiplying both sides by the half x. So multiply this by half x, that clears it off the bottom. Multiply this side by half x as well. And what we get is h equals half of x times tan of 60. Now if I go back to my special angles here, 60 degrees is actually a special angle. Let's just draw it on a unit circle so we can refresh our memories here. So that wasn't a very circular circle. All right, there's 60 degrees. The y part here is going to be sine. The x part here, that would be cos, right? So sine of 60, if you remember, is root 3 over 2. That's the long part of the 60-30 triangle. Cos of 60 is 1/2, and tan of 60 is the sine of 60, which is root 3 over 2, divided by the cos of 60, which is 1/2. You're going to want to flip that bottom fraction and multiply. That'll give you tan of 60. It's actually just equal to root 3, right? The 2 here will cancel with the 2 there when you do the multiplying by the reciprocal. So just to refresh our memory of special angles, tan of 60 here is just root 3. So we can replace that. So I have h is 1/2 x times root 3. And I can make that a little simpler. I'll get h is root 3 over 2x, right? If I multiply the root 3 by the 1 in that fraction, this is the same as root 3 over 1, so I can kind of multiply those fractions out and get root 3 over 2 times x. All right, so all that work just to find the height of this triangle. So the height of this triangle is root 3 over 2 times x. What we want, though, is the area of that triangle. So I'm going to erase a little bit of stuff here so I have more room. So I'll write in h. So h we found was equal to root 3 over 2x. So let's erase some of this stuff just so we have a little bit more room. Our next goal is going to be to find the area of one face triangle. So that means the area of this whole thing here, or the area of this whole triangle that I've drawn in 2 dimensions there. So if you remember, area of a triangle is base times height divided by 2. In our case, the base of this entire triangle here is x, right? That's the base there. The height we just solved for. The height is root 3 over 2 times x. And then that whole thing is over 2. That looks a little bit messy, so let's clean that up a little bit. That is a fraction divided by a fraction. The fraction in the bottom is actually 2 over 1. So we could write that as 1/2 times this whole thing. I'm going to make that a little bit cleaner. Sorry. Actually, I'll write the top first. So you've got x times root 3 over 2x, so that'd be root 3 over 2 x squared. And that whole thing is being multiplied by this fraction upside down, so 1 over 2, the reciprocal of that. Which gives me root 3 over, so root 3 times 1 is root 3, 2 times 2 is 4 times x squared. So that's the area of one face. Just one of those triangles. Now let's think about, well, how many triangles are there altogether? Well, there's 4 of them, right? Because this is a square-based pyramid, so there's 1, 2, 3, 4 of those triangular faces. And there's also a square base on the bottom. So the area in total is going to be, first, the base on the bottom. The base on the bottom is just x by x. If I kind of draw the base out over here, it's literally a square, x by x. So the area of that base is just x squared, x times x, plus 4 of these triangular faces that I just found. And each triangular face has an area of root 3 over 4 x squared. So that means my total area must be x squared plus, let's simplify this, so 4 over 1 times root 3 over 4. It looks like the 4's will cancel there, right? And we'll get just root 3 times x squared. That root just goes over the 3, not over the x squared as well. And we can't simplify this anymore because we're told it has to be exact, so I can't sort of square root that 3. I'm just going to leave it like that. That is my total area of this shape. And that's it.